this video we will learn how to do a multiplexer in VHDL with the case statement. So let's open Vivado, create project, next, we'll call it MUX, next, of course I'll choose the Basys 3 FPGA board, next, finish. So first let's change the target language from Verilog to VHDL. Okay. So let's add sources, add or create design sources, next, create file, we'll call it top, okay, finish. So now we need to specify the input and output ports. So we have A1, the first input of 2 bits, we have A2, the second input of 2 bits, we have A3, the third input of 2 bits, we have A4, the fourth input of 2 bits, then we will have the selection bit, cell, also an input of 2 bits, and then we have B, which is the output of 2 bits. Okay, so now Vivado is creating the top.vhd file. We can open it. Okay, so now we need to declare a process. In the sensitivity list we need to put all the input signals. So now inside the process we need to declare the case statement. So we have case cell is, so when 0 0 B is equal to A1, when 0 1 B is equal to A2, when 1 0 B is equal to A3, when others B is equal to A4. So end case. So now Ctrl S to save, and now we can run the synthesis. Okay. Okay, so the synthesis is finished, so we can open the synthesized design. Okay, so now in I/O ports we need to connect the input and output to the actual LED and switches on the FPGA board. So we have A1, so the first bit will connect it to the first switch, R2. The second bit will connect it to T1. The standard is Elevisimos 33. Okay, then we have A2, we connect the first bit to the third switch, which is U1, and we connect the second bit to the fourth, which is W2. The standard is Elevisimos 33. Then we have the third input. The first bit will connect it to the switch R3, and the second bit will connect it to the other switch, which is T2, sorry. Standard Elevisimos 33. Then we have the fourth input. The first bit will connect it to the T3 switch, and the second bit will connect it to the V2 switch. The standard is Elevisimos 33. Then we have the output. The output will connect it to the first two LEDs, which is L1 and P1. The standard is always Elevisimos 33. Then we have the selection signal. The first bit will connect it to the W13 switch, and the second bit to the W14 switch. The standard is always Elevisimos 33. So now Ctrl S to save, and Vivado will create the constraint file. Okay. Now we can generate the bitstream, and of course Vivado will relaunch the synthesis. So we can close the synthesize design. Okay, so the implementation is completed, so we can open the hardware manager. Okay. So we can open target. First we need to turn on the FPGA board, then auto connect. So we can program the device with our bitstream program. Okay, so now we can try all the combination. So as we know, the W13 and W14 are the selection bit. So when the selection bit is 0, 0, B is equal to A1. A1 is the first two switches. So as you can see, the output follows the first signal. So now, if we switch on the W13 switch, B should follow the A2 signal. So as you can see, then if we switch on the W14 switch, B should follow the A3 signal. And then if W13 and W14 are high, B should follow the fourth input. So thank you guys for watching the video. Please remember to leave a like, subscribe, and follow me on Facebook and on Instagram. See you in the next video.